The contactor is one of the components in a control system that's used to control the operation of an electric load. Contactors cause sets of electrical contacts to open or close automatically to either energize or de-energize system loads in response to the load requirements. The two main components of the contactor are the coil and the contacts. The contactor coil generates a magnetic field, which pulls the contacts closed, energizing the system load that's being controlled. Contacts on the contactor are connected to an armature that helps ensure that all sets of contacts open and close at the same time. Contacts are rated by their current carrying capability. Large loads require contactors with a high current rating. In this schematic diagram of a small residential air conditioning system, the two sets of contactor contacts are used to energize both a compressor and a condenser fan motor. In larger systems, each compressor or fan motor may very well be controlled by its own contactor. When a contactor fails to operate properly, there are three areas that need to be checked: the coil, the contacts, and the mechanical linkage. The failure of any of these parts will cause the contactor to malfunction. The coil of the contactor can be easily checked with an ohm meter. If the resistance of the coil is infinity, the coil is said to be open and must be replaced. Infinite coil resistance indicates that there is a break somewhere in the coil. Some coils, such as those on a potential relay, have very high resistances, so the proper resistance scale should be used. If the resistance reading through the coil is 0 ohms, the coil is shorted and must be replaced. If there is a measurable resistance in the coil of the contactor, chances are that the coil is good. The contactor contacts should be smooth. A visual inspection can be done to check the condition of the contacts. Here we see both good and bad contacts. Contacts can also be checked with either a voltmeter or an ohm meter. When checking the contacts with the voltmeter, the test leads of the meter should be placed across the contacts as shown here. The coil of the contactor should be energized and the contacts should be in the closed position. A voltage reading across the contacts that exceeds 5% of the supply voltage indicates that the contacts are pitted or bad and need to be replaced. If an ohm meter is used to check the contacts, there should be no current flowing through the contacts, but the coil should be energized. The wires should also be disconnected from the contactor contacts. When the contacts are in the closed position, the resistance reading through the set of contacts should be very close to 0 ohms. Always be sure to check all sets of contacts. A high resistance reading indicates that the contacts are no good. The mechanical linkage of the contactor can be checked by simply moving the armature of the de-energized contactor. The linkage should move freely.